Okay, today we're going to do 4-8 coordinate proofs. Position figures in the coordinate plane for use in coordinate proofs. Prove geometric concepts by using coordinate proof. Okay, you have used coordinate geometry to find the midpoint of a line segment and to find the distance between 2 points. Coordinate geometry can also be used to prove conjectures. A coordinate proof is a style of a proof that uses coordinate geometry and algebra. The first step of the coordinate proof is to position the given figure in the plane. You can use any position, but some strategies can make the steps of the proof simpler. Strategies for positioning figures in the coordinate plane. Always use the origin as a vertex. Keeping the figure in quadrant 1 is best. Center the figure at the origin. Center a side of the figure at the origin. Use one or both axes as sides of the figure. Okay, what's this mean? Position a square with side length of 6 units in the coordinate plane. Okay, so let's draw our y-axis and our x-axis. All right, we're going to need to position a square here. I want one of my coordinates right here at the origin. That's 0, 0. Side lengths are 6. 1, 2, 3, 4, 5, 6. So I have 6 tick lines. This is going to be my second coordinate. 1, 2, 3, 4, 5, 6. This is going to be my third coordinate. And then my fourth coordinate, remember, square, all segments are congruent, so I have to go right 6, up 6. So this coordinate will be 6, 6. And we've just positioned a square in the coordinate plane. Now we're going to position a right triangle. All right, let's see. We've got leg lengths of 2 and 4 units. You always want to put the vertices of the right angle at the origin, because you know anytime you have a vertical and horizontal line, that creates a right angle. Okay, so one leg is 4 units. And one leg is 2 units. So there's my right triangle. Now, could we have done it the other way? Yes. We could have gone 2 here, and we could have gone 4 here. You still have a right triangle with legs of 2 units and 4 units. Once the figure is placed in the coordinate plane, you can use slope of the coordinates of the vertices. You can use the distance formula. You can also use the midpoint to prove statements about the figure. Okay, so we've got rectangle A, B, C, D with these vertices, and we're going to prove the diagonals bisect each other. Okay, so our diagonals are D, B, and C, A. We want to know that they bisect each other. Okay, well if they bisect each other, they intersect where? At the midpoint. So we want to think midpoint formula. Okay, so midpoint formula. X subscribe 1 plus X subscribe 2 divided by 2. Y subscribe 1, Y subscribe 2 divided by 2. So there's your midpoint formula. So let's take the midpoint of AC. AC. So we have A, which is 0, 0, and we have C, which is 4, 10. So I'm going to take 0 plus 4 and 0 plus 10, and I get 4 over 2, which is 2. I get 10 over 2, which is 5. So there's the midpoint of AC. Now we need to find the midpoint of DB. Okay, so right here's D, right here's B. So what we have here is 4 plus 0 over 2 and 0 plus 10 over 2. When you simplify that, you're going to get 2/5. Okay? Once you prove that their midpoint coincides, which means they intersect, then you've proven that the diagonals bisect each other. So you might want to put midpoint coincide. Therefore, you know that the diagonals bisect. All right, a coordinate proof can also be used to prove that a certain relationship is always true. You can prove that a statement is true for all right triangles without knowing the side lengths. To do this, assign variables as the coordinates of the vertices. Position each figure in the coordinate plane and give the coordinates of each vertex. Rectangle with width m and length twice the width. All right, so we're just going to position still. So let's make our y-axis and our x-axis. We always want to start here at the origin. There's 0, 0. Okay, so let's see. The width is going to be m. So this is going to be my width. So this will be 0m. How do I know that? Because the measurement of this distance here is m. All right. The length, which is going to be this, is going to be twice the width. Well, if the width is m, the length is going to be 2m. So this vertex here is going to be 2m, 0. And then our last vertex, whoops, there's a little bug there. Okay, so we go right, 2m, and we go up, m. And there's our rectangle. Okay, now we're going to graph a right triangle. All right, remember, let's start here to get our right angle. All right, with legs of S and T. Okay, does it matter which way you go? No, so I'm going to go right S units. So this is S0. And I'm going to go up T units. So it's 0T. Okay, because the length here is S. The length here is T. So that's how I'm getting those coordinates. Position a square with side lengths 4p in the coordinate plane and give the coordinates of each vertex. Okay, I'm going to be quiet and let y'all do this one on your own. Okay, last one.